After 4 years of daily driving Arch Linux, I'm leaving. And you may think I'm leaving because Arch Linux breaks often or because it's unstable, but the reason why I'm leaving is actually very different. I'm going to be running my workflow like a Kubernetes cluster. I want a workflow where I can throw my laptop in the sea and restore it to a new machine in 10 minutes. And in this video, I'll explain how I'm going to build the workflow of my dreams and why I have to leave Arch to do this. I will teach you about modern software deployment practices and how you can apply them to your own setup as well. So let's dive in. I'll start by explaining why I'm actually doing this. You see, KubeCraft, my business, is actually going places. It is growing fast and we're doing really well. So me and my brother, who is my co-founder, we actually decided to rent an office space where we can build an even more professional studio to create YouTube videos and to collaborate together. So this is really exciting, but this also means that my trusted little setup here is going to be moving elsewhere and that I'm going to be working from several places now. So I need my workflow to be available here at home when I'm in the office, but also when I'm traveling around Europe in my camper van, because I have that remote location freedom right now as a business owner. So my workflow needs to be optimized for this. And obviously, when you set up a new office and a new studio, you also need to buy new hardware. And this has been a bit of a process where me and my brother were thinking, what are we going to get? My brother is more of a computer normie, whereas I preferably want to run everything on Linux. So I decided to go for Framework. Framework is a company that creates laptops, which is completely aligned with my values and what I like to see. So you configure once, upgrade whenever. It's a modular system, and you just create your laptop and you can replace your parts. You have the right to repair, you have control over your system, and this is completely up my street. I love this. I'm tired of paying $2,000 for 1 terabyte of storage on a MacBook, and I'm tired of big tech companies spying on my computer use. So what I bought for myself is a Framework 13. This is going to be arriving in a few weeks from now, and I'm super excited to start using this because this is going to be my portable workstation. And secondly, I've also ordered one of these Framework desktop computers. So you may know that last year I built this massive workstation with a 9950X AMD CPU and a 4090 GPU. And that has been a great machine. I've been running Arch Linux on there for well over a year. But when I was talking to my brother, we actually came to the conclusion that I wasn't using this GPU as much. So I thought that I would be playing some video games, but I'm just too busy working all the time. I don't have time for games. So he is more interested in that kind of stuff. So I bought that GPU also to experiment with AI. And for that, it has been extremely useful. However, we decided that maybe he would be better served with this big workstation with a 4090 GPU, and that I would go for a Framework desktop. You see, a Framework desktop has this very interesting thing, and I'm not completely sure how this works yet, but what it does is, like normally a GPU has VRAM. So let me draw this out for you. This is my GPU, and a GPU has VRAM. And I think my GPU has my 4090 has 24 gigabytes of VRAM. Now, the amount of VRAM that you have determines how large a model you can load into that GPU. So the more VRAM you have, the larger models you can run. And this can run a pretty decent model, but you can't run OpenAI, the open source version of ChatGPT, right? Now, these Framework desktops, they get up to, what they do is they share the VRAM with your normal RAM, I believe. So you can get up to 128 gigabytes of VRAM. And this means I can load much larger models. Now, there's a caveat here that this setup is going to be running the models much quicker, but with this setup, I can run larger models, and it might be a bit slower, but I can at least run them. So this is a more interesting setup for me at the moment. So I'm basically buying a Framework desktop to have here at home, and then my Framework laptop to have as a portable device. So I'm really excited about this. So I will have all of this new hardware to set up, and I'm taking this as an opportunity to try something completely new and to implement something that I have been really wanting to do for a long time, which is something that I call the stateless workstation. And this stateless workstation concept is something that I came up with by applying my principles that I do in my work as a DevOps engineer to my own personal computing. And one of these concepts in engineering is called cattle versus pets. So in traditional IT, you would have these servers and they would be configured by hand, and all of the binaries are there, and it's sort of a little bit of a mystery how everything is configured, but it works, so we should probably not touch it as too much, right? This sort of idea of a sensitive pet that you don't want to poke too much, and it's a very special snowflake kind of thing. That is the traditional approach of pets, where these servers are very peculiar and particular, and if one of these servers dies, you have a big problem, right? Now, in modern IT, you have the concept of cattle, servers as cattle. And this means that each server is basically either defined in code or as an image or as some sort of mechanism that makes your servers reproducible. So when you have a Kubernetes cluster, you have a control plane, and then you have worker nodes that are being provisioned. So, and then your workloads are being scheduled on these worker nodes, right? Now, to add or remove one of these worker nodes, you do not want to have to sit there and manually run a few scripts, install all of these binaries, etc. No, that doesn't work that way. Kubernetes services generally work is that they will create some sort of an image that is then being deployed to a virtual machine. And then all of these nodes are practically identical and then being loaded into the cluster. And likewise, in cloud engineering, you have the concept infrastructure as code. And if you're not familiar with this, what this means is that if you have a cloud environment, right, a big company that has many different teams and many different applications, what happens is if you start managing this by clicking in the web browser and just clicking everything together, then yes, you will get your resources, but there's no way of reproducing those if something goes wrong. Or if you have, let's say you have 5 development teams in your company, and each of them requires roughly the same resources in the cloud. Now, if you start with one team and you create everything and you manually set it up, if you then want to repeat that for the next team, then you don't really have a mechanism to copy and paste that in the cloud, right? So what was created was infrastructure as code, where you simply write the code in a file, usually with Terraform, and then you specify, okay, I want a virtual machine with this type of disk. It needs to be connected to this network. And oh, by the way, let's first create a network. So I need a network with this CIDR range, and it needs to be paired with that network. So you in code, you define the state that you want to have, and then these tools are going to talk to the cloud and make it so, and provision that, right? That is the concept of infrastructure as code. So you have a file that defines what you want, and the tools make it so. And this is called declarative, a declarative approach. Now, what I want to do is I want to take a declarative approach to my entire workstation and to multiple workstations. And I want to treat my workstation not as a pet anymore, because my current Arch Linux workstation, it's a pet. I created it, I have the packages, and I know how it works, but I cannot just simply take that and copy paste it to a different system and everything would run. That's not how this is currently set up, unfortunately. So my current workstation is a pet, whereas I want to move to cattle. I want my workstations to be instances of the same workstation. I want to be able to get a laptop, throw it into the sea, get a new one, and then be up and running in 10 minutes. And with that, I mean not just my dot files, I mean all of my files that I want. I mean my specific configuration for all the applications that I use. I want all my applications to be installed on there and have them configured out of the box. Literally just copy pasting my whole workstation setup. And that's what I'm going to be building over the next few weeks. I'm going to be daily driving Linux on every machine I own, and each of these machines needs to be provisioned in less than 10 minutes. That's the workflow I'm going for. So why do I have to leave Arch for this? Why can't I just do this with Arch Linux? It's a good question. And actually, there are several reasons why I want to leave Arch. The first of them is that with the laptop that I'm going to get, I want to have a little bit of a more streamlined experience. I do not want to be messing with my sound via the CLI. I want to have, like this in Cosmic, I want to be able to just open up my settings and easily change it and have no issues with setting that up. Now, I can do that with Arch. I can build an Arch Linux system and load Cosmic on it, and it would work, right? But I've been getting too comfortable with Arch. The thing is, Arch still has this reputation of being super unstable and that things break all the time. And it's simply not true. Like my latest workstation build, I've been running that for almost 1.5 years. And I literally never had any problems at all. Like literally, it really is really good these days. So the thing is, that is not the reason to leave Arch. It is really stable, so much so that I've gotten comfortable with it. And whenever I get complacent, whenever I get comfortable with something, I know that I need to change things up a little bit, right? Now, don't get me wrong. I arrived at this level of mastery after several years of practice, right? I still believe that running Arch Linux, daily driving Arch Linux, will teach you Linux on a level that you're not going to get anywhere else. Being your own system administrator and being in control of your system on that level, so knowing each and every process because you put it there, that is the level of mastery that I think is a good level to be at, especially if you aspire a career in the tech industry, whether that is going to be as a software engineer, a system administrator, DevOps engineer, Kubernetes engineer, or AI engineer. If you are able to reliably run an Arch Linux system that you built yourself from scratch, you are going to be 10 times better than anyone else in that role by definition. That is a strong statement, but it's true. Running Arch Linux over a longer period of time and maintaining that properly will teach you Linux on a very deep level. So to learn Linux, Arch is the way. Arch is the best way to do it. It's not a meme. It is an extremely, extremely useful skill to have in your life. Now, I have come to a point in my career where that is not a challenge anymore. It's easy, and that's why I want to try something else. The second reason is that my system has become a bit of a pet. So I could technically export all of the packages that I installed with Pacman. You can just export that as a text file, export all of my packages that I installed with Yay, and then create a new system, install those packages, and I would basically be good to go again. So in a sense, I could do that, but it's not as fast and as clean as I would like it to be. Instead, I'm going to be trying something that's called an immutable OS. I encountered the concept of an immutable OS for the first time when I started working with Talos Linux. So this is the Kubernetes operating system. It's a very minimal Linux distribution that basically installs in Kubernetes cluster for you, and that's it. It's completely secure by default. You don't have anything else. It just exposes an API, no SSH access, and it's immutable. You cannot interact with the operating system like you would do with a normal Linux system. And when you update it, you don't update packages on that system. You update the entire system. So a new image is loaded, and that is booted. And if everything works, great, you finish your update. So I first encountered this with Talos Linux, but then I also discovered this is also being applied to desktop environments. So Fedora makes these atomic desktops, which are immutable OSs. So let's take a look at Fedora Silverblue. So Silverblue is the GNOME version of their Atomic desktops. And let's see what they have to say about it. So why would you choose Fedora Silverblue? It's reliable. So each version is updated for approximately 13 months, and each update takes effect on your next reboot, keeping your system consistent. You can even keep working while the updates are being applied. So this means that instead of updating one package at a time, the whole image of your operating system is updated instantly. It's atomic, so the whole system is updated in one go, and an update will not apply if anything goes wrong, meaning you will always have a working computer. Again, you create this image with all of the new updates baked in, and you don't do it like Fedora does this in the background. And then on your next reboot, this new image, this new snapshot of your entire operating system is loaded. And if anything goes wrong, you can just reboot, load your previous snapshot, and you're back and off to the races again. Like I say, you will always have a working computer. A previous version is always kept around. And here, this is where it gets really interesting. Everything is containerized. So graphical applications are installed via Flatpak and keep themselves separate from the base system. They also allow for fine-grained control over permissions. I was not aware of Flatpacks. On Arch Linux, I just install either locally or in dev containers, right? But you can see that these Atomic desktops, they are optimized for containerized workflows. And this is completely up my street. Here you see that sometimes you have to leave something in order to get better at something. So in my case, I need to leave Arch Linux because I'm a bit in my own Arch Linux bubble and I know how it works. But now I want to try something radically different, which is an immutable OS, an Atomic desktop, and use that for a while. And you see, this is completely optimized for containerized workflows, which is completely up my street because I already do almost all of my work inside of containers. Let me show you what I mean by that. So if I run which kubectl on my host system, it will say there's no kubectl found in my home system. Like kubectl, it doesn't exist on my system. And I install all of the packages that I need only inside of containers. So if I want to work on a project, I will create something that's called a dev container. And that dev container contains all of the packages and the tools that I need in order to develop on that project. Let me give you an example. So I created this Kubernetes benchmarking tool. It's a CLI tool that will run disk SPD on your Kubernetes clusters. But that is not living on my system currently. But let's say I want to work on that project right now with all of the tools that I need for it. Well, what I would run is Devpod up. Devpod is the CLI that I use to create my dev containers. I give it the repo, I give it the dot files I want to load, and it will clone that repo. It will then start building the environment that I have defined in code. So it's an application of infrastructure as code that like I explained you. It is now installing Mies, kubectl, Python, the Python version that I want. Now it's cloning my dot files. And after it has cloned my dot files, it is now going to be installing all of the packages that I want to have available wherever I am. So in my case, that is like fd, lazygit, fcf, neovim, of course. And now, when I do devpod ls, I see that I have my split bench container available. So devpod ssh, I select my split bench, and Mies is then going to automatically install my virtual environment. And here we go. If I do which Python, my Python installation is installed. And if I open up my editor, it is then going to install all of the configuration that I have defined in the code for that. And now I can start neovim, and I have fcf already available. So if I open my cli.py, it is now going to install all of the language servers that I want for my Python development project, and everything is up to date and everything is done as I want. And now you see that my language server is saying the imports could not be resolved. So what I do is I do uv sync. uv is already installed for me. uv sync has now installed all of the packages. So if I open it again, now you see everything is resolved and I can develop my Python project with everything that I need. It has auto completion. I can I can write my functions like this, etc. So it has everything, like the full editing environment is configured. But also, if I open my mies.toml, you see that this will install K9s, kubectl, etc. in this environment. So if I do which K9s, we see that K9s is installed. Which kubectl is installed. If I open up a new shell, which kubectl on my host system, there is no kubectl. There's no K9s. So this is how I already have a stateless workstation, in the sense that every project that I use, every project that I work on, gets its own repository with the complete environment defined in it, and I can easily get up and running within seconds, as you have seen. Now, if you want to know how this whole workflow works, then check out KubeCraft. In there we have DevOps OS. In here I teach you everything you need to know about Linux, and then I'm going to continue teaching you this whole dev container workflow. So you get my dot files, a plug-and-play template, so you can get up and running really fast with this, but also an 8-hour course that is going to explain everything about my NeoVim configuration, how this dot files workflow works, how all of this dev container workflow is done. I will teach you how to build a Kubernetes home lab. I have a full DevOps masterclass, and all of this is there to land you a 6-figure DevOps job within 2 to 20 weeks. And this is working really well for people. Amha got a new job and a 50K raise. Endrit here got a fully remote SRE role with the help of his AWS home lab. And all of these skills they learn here in KubeCraft. So if you want to make 200K plus a year as a DevOps engineer, KubeCraft is the way. Check it out. So a large part of this stateless workstation I've already created by using dev containers, right? The second thing I really like is that these atomic desktops, they rely on Flatpacks. And to be honest with you, I was not very aware of Flatpacks. I mean, I knew the name, but I never installed packages with Flatpacks. But actually, now that I'm looking into it, it seems like a much better way to run and create software. Because your applications with Flatpaks, they are all packaged with the libraries that they need. You see here, if an application requires dependencies, they can be bundled with the application. So your application will always work. And Flatpak runs these in sandboxes. Each application is built and run in an isolated environment called the sandbox, and each sandbox contains the application and its runtime. By default, the application can only access the contents of its sandbox. Access to user files, network, and graphics sockets have to be explicitly granted. So I love this. This is such a much better way of running software on your system instead of installing it locally and just letting it access your entire system locally. So I'm really excited about this. And again, this ties back to this idea of getting out of your shell, trying something different, trying something new, and learning new things, right? Because I am not leaving Arch forever. I can spoil that surprise now. I'm not going to leave Arch forever. I'm going to set up my laptop as an immutable OS. I'm experimenting with it. And I want to create a workflow that I can provision from scratch within 10 minutes. But I think I will take those learnings and then apply that back to Arch Linux again. That is my whole plan here. And I imagine that I'm going to be using Flatpaks a lot more when I come back to Arch Linux. And that way I will have learned. But I don't know yet. This is all going to be a journey, right? And I'm going to be documenting this entire journey. So I'm going to be actually wiping my Arch Linux system and then, okay, well, I have my system, I have my backups. Can I actually restore it? Can I actually do it? I'm preaching this stateless workstation, but how stateless is my workflow? And I'm going to be documenting all of this as I go along. So if that sounds interesting to you, make sure that you subscribe because I'm going to be documenting this entire process. So this whole project can be summarized as the stateless workstation. So I'm applying infrastructure as code principles to my workstation. Cattle versus pets. My workstations are going to be cattle instead of pets. The second element of this is syncing my files. So you do need to have some sort of file system that is going to be carried over to different workstations. Like I need to have access to my business documents. I need to have access to all of my assets, my social media profile pictures, all these kinds of things. So there is a certain set of files that I want to be available on every workstation that I have. And the current solution I have for that right now is Synology Drive. In my home lab, I'm running a Synology, and that has a application called Synology Drive. And what this does is it basically is an iCloud drive, but then in a self-hosted fashion. So I can set up my Synology Drive application, point it to my Synology, and then the application is going to be syncing those files from my own self-hosted system. It's basically a self-hosted iCloud drive. And I've been using this already, so I'm also already syncing files between my MacBook and my Arch Linux workstation. But now I'm going to use this as the central hub of all of my files. And I'll explain in a future video exactly how I set this up, so make sure you're subscribed. The third element is going to be applications as Flatpacks. That's also going to be completely new to me. Everything in containers, I already do it, but I want to test how portable all of this actually is across multiple devices. And in order to do that, I need to have my dev environment in code. And that problem is already solved. So after I stop recording this video, I will record a final video on this Arch Linux workstation where I give you a full tour, which is coming next week. And before I wipe it, I just wanted to have one last video, and then I'm wiping it, and then it's time to reproduce my environment and see how stateless everything is. That's what's coming in the next few weeks. So I hope this made you think about your own workstation setup. If you cannot throw away your laptop and basically recreate it in less than an hour, you have work to do. If you haven't done any backups of your workstation, stop watching this video right now and start making backups. I have a video about that over here. And if you want to apply these principles to your career, if you want to land a six-figure job as a DevOps engineer, I have the full system ready for you in KubeCraft, where I can teach you DevOps from the ground up. I'll teach you how to create a home lab, how to land these DevOps interviews, and how to make recruiters message you instead of you having to apply. We are landing jobs every single week in KubeCraft, and you can be the next one. Check it out, the link will be down below, and I'll see you in the next video.